Okay, in this video we're going to take a look at solving quadratic equations by factoring, which is part of this unit on just solving quadratic equations. So this is the first method that we will have. And here's some steps, and we'll do some examples along with these steps. So the first step is to set our equation equal to 0 and put the equation into degree order. Once I have it equal to 0, then I'm going to go to step 2, which is to factor the equation. And we have lots of factorization techniques, so we'll explore a couple of those with some of the examples. And then, once we have factored, we set each factor equal to 0. We solve each of those new little mini equations. And finally, we check our solutions to make sure that they actually work. Okay, let's create a little bit of space here, and we'll try 3 examples all at the same time to work through these steps. Okay, so here are 3 examples, one in black, one in blue, and one in green. And we'll just work through these same 3 steps for all of them. So the very first one is to set the equation equal to 0 and to put it into degree order. So degree order is from the largest degree, things like x squareds, all the way down to just the constant terms at the end. So usually it's x squared, then the x terms, then the constant terms at the end. But it depends on the variable. You see I've got some x's in the first one, I've got z's, and then I've got y's. So we're going to put any of these all of these into degree order and make them equal to 0 at the same time. To do that with the first equation means that I take this positive 20 and I need to move it to the other side so that this is equal to 0. That means I'm subtracting 20. So there's the x squareds, and then the x's, and then we subtract 20. To do it for the second equation, I have to get this z to become 0. And so I subtract z on this side to get 0, and I subtract a z on this side, so I get z squared minus z. That's in degree order of the squared ones than the regular ones. And then let's take a look at this last one. I've got this 4y on this side, so I have to add 4y to make this side equal to 0. And that 4y I'm going to put in after the y squareds so that this is into degree order. Perfect. Now I can move on to step number 2, which is to factor. So this first one, I need to remember the previous learnings on factoring. I have to do 3 times negative 20, that would be negative 60, and find 2 factors that add up to the middle term of negative 7. So I can think about, is it 1 and 60, or 2 and 30, or 3 and 20, or 4 and 15, or 5 and 12. Oh, 5 and 12 might work. So I want it to be negative, so positive 5 and negative 12. And so I decompose this to plus 5x minus 12x minus 20 equals to 0. So this factoring step could take a few steps. In the first 2 terms, I see a common x, leaving over 3x plus 5. In these 2 terms, I see a negative 4, I think, is the biggest number that goes in. And I should get the same thing in these brackets. So this will be 3x, and then negative 4 out of negative 20 will give me plus 5. And so I factor this to 3x plus 5 times x minus 4 equals to 0. Doing the same thing with the second example, I look at these 2 terms and I say, oh, I have a common factor between 2 terms of a z, and that would leave over a z minus 1. So there's the full factorization. And in the last one, actually the easiest one, I factor this. I need 2 numbers that multiply to 3 that add up to 4, and since this is a 1 in front, when I find that it's 3 and 1, I can just put in 3 and 1. So I have everything factored. I can now move on to my next step of setting each factor equal to 0. So this 3x plus 5 could be equal to 0. This x minus 4 could be equal to 0. In the next one, here's a factor. That's z could be equal to 0. And another one of z minus 1 could be equal to 0, and here I have y plus 3 could be equal to 0, and y plus 1 could be equal to 0. And now I move on to step 4, which is to solve each of these. So this is actually, this first black example is the most complicated one, I think, out of all of the examples I'm showing you, because these are a little bit more complicated to solve. But I subtract 5, and then I divide, and I get negative 5 over 3, and I add 4, and it looks to me like these are my two solutions. When I move on to the next one, this one's already solved, and this one I just have to add 1 to each side. It looks like those are my solutions, and I subtract 3 and subtract 3. That looks like one solution, and there's another solution. And now I can go and check my solutions and see if they actually work out. So starting with maybe the blue one first, because this one's a little bit complicated, but the blue one first. If I put 0 in here, is 0 squared the same as 0? It sure is. So yep, that's for sure a solution. And is 1 squared the same as 1? Plugging this one in. Yep. So that was a fairly easy one to check. Checking this one for negative 3 is negative 3 squared plus 3 the same as negative 4 times negative 3. Well, this is 12, and this is 9 plus 3. So yes, that one works. Checking negative 1, I do negative 1 squared plus 3 is equal to 4 times negative 1. This side's 4. This is 1 plus 3, which is also 4, so this one works. Now let's go back and check these ones. I'm going to do the x equals 4 one first because it's a little bit easier. So is 3 times 4 squared, so 4 squared is 16. 3 times 16 minus 4 times 7 is 28. So is 48 take away 28 20? It sure is, so that one's okay. So now we can check this last one. 3x squared minus 7 times x, does that equal 20? So I'll square this one, so 3 times 25 ninths. And negative 7 times negative 5 is plus 35 thirds. Is that 20? And this 3 and this 9 can cancel. So 25 thirds and 35 thirds, is that 20? And 25 plus 35 is 60 thirds. So 60 over 3, that is 20. And so this one works as well. We'll get lots of practice of this in class. See you then.